Okay, so we're going to start by talking about kinematics, which this is going to be very similar to what we were doing at the end of last semester. It just has a different name. So we'll start with just our original f of x function. F of x is now going to be known as our position function. Usually it's represented with x of t or s of t. The derivative of the position function, it gives us velocity. So now f prime of x is known as velocity, which we represent with v of t. And then lastly, the second derivative of the original graph, of the position graph, is now acceleration. And we represent that with a of t. So there's a couple of things to keep in mind when we're talking about these that have to do with the more physics words. So keep in mind when we talk about the derivative, we're talking about the slope. So velocity is the derivative. So this is the slope of the position graph. So it's also known as the slope if the velocity is positive, meaning if it's above the x-axis, if the y value is positive, then that means that the particle is moving to the right. If it is negative, if the y value is below the x-axis, then that means that the particle is moving to the left. Okay, if it is 0, then the particle is at rest. If its velocity is 0, then it's not moving, and usually the word we use to describe that is at rest. Okay, so for the position now, when we talked about it moving right, we said that the derivative's y value was positive, meaning that the slope of x of t is positive. If the slope is positive, then the word we use to describe that is increasing. So if it has a positive slope, if it is increasing, that means that the particle is moving to the right. If the particle is moving to the left, then that is when it is decreasing. Okay, and then lastly, we have our acceleration. So this is the second derivative, which means we look at the concavity of the original graph of x of t, or we can look at the slope of v of t. Okay. When acceleration is 0, then we know it's a point of inflection on x of t. And we know that it's a max or min on velocity. Okay, so that's I know that some of this might sound different, but really you've already learned this lesson, which is a nice way to start the semester. Moving on from there, we can say that speed, often in English, we use this word interchangeably with velocity, but they don't mean the same thing. Velocity is a vector, meaning it has a direction, but speed is not directional, so it's positive. Velocity could be negative, but speed isn't. When the velocity sign matches the acceleration sign, then we say that the object is speeding up. And then in the opposite direction, if velocity sign does not match the acceleration sign, so if one is positive and one is negative, then the object is slowing down. Okay. When velocity is 0, we say the object is at rest. When we talk about displacement, that's the distance from the starting point. So if I were to take 2 steps forward and then take 2 steps back, I actually ended up at the same point. My displacement, the distance from my starting point, is 0. I ended up at the same point. But on the other side of it, when I look at distance, if I take 2 steps this way and then 2 steps that way, I've actually taken 4 steps. So distance is different than displacement. And the way that we look at distance is to look at the max and mins. So this would be a maximum in one direction and a minimum in the other direction. So I count how many did I go up and how many did I go down, and that's how I get distance. And you'll get a lot of practice on this with delta math. And so from there, let's go ahead and talk about that a little bit more. I'm going to go through the demonstration. It's a little bit difficult to do, so I thought it would be helpful for y'all to see an example first. But the more familiar and the more confident you get with this section, the easier this activity should be. Okay, so I'm going to go through a particle motion guided example for you. So what I like about this is it allows you to re-look at the graph and you can see the object moving. So our object in this case is a bunny. And I personally think that the hardest part of these questions is figuring out where you're supposed to start. So I'm going to take a look at my position graph. Now from 0 to A, I see that the object is that the graph is increasing but concave down, which means that I want my velocity to be positive, but the slope of my velocity to be negative, which means that I need to start above 0. Now, I know that part of it was confusing, but one way you can do this is just to play around with it until you understand it and it's working for you. But so from 0 to A, I know that up here at the maximum, the particle is at rest, meaning that the velocity is going to be 0. So I'm going to move this down to 0. Then my point A showed up. Now my velocity is negative because the slope of this graph is negative, and it's concave down, which means that the slope of velocity will also be negative. So now I want my y values and the slope to be negative. So I'm going to keep continuing in a negative direction. And then now I have hit point B, where my slope is now changing a point of inflection. So I want to change directions. I want the slope here is negative, meaning my velocity graph is still going to be negative, but now it's concave up. And if it's concave up, then that means the slope of velocity is going to be up. So now I need to go back the other direction. Okay, now I've reached point C, where the object is at rest because it's at a maximum or minimum. Now my velocity, the slope here is positive, meaning I'm going to have positive y values. It's also concave up, meaning that it is going to have a positive slope. So I'm just going to continue in the same direction. And that's it. So the more you practice these, the easier they'll get. But now the cool thing about being able to answer these questions, I pretty much answered all of them for you, but we can go through them together as well. But we can look at them by watching our animation again. So this first question from 0 to A, is the bunny moving to the right or to the left? Well, I see that it's moving to the right. And then from A to B, it's moving to the left. From B to C, it's still moving to the left. And from C to D, it's moving back to the right. Okay, now I'm going to look at velocity, meaning I'm going to want to look at this V of t graph. And I'm looking at the y values. From 0 to A, the y values are positive. From A to B, the y values are negative. From B to C, they're negative. And from C to D, they're positive. The next question wants to know, is it increasing or decreasing? So now I'm going to be looking at the slope. So the slope of this velocity graph that we made from 0 to A is decreasing, then decreasing. Next, it's increasing and increasing. Now, acceleration should match the slope of velocity. So decreasing means negative and increasing means positive. Lastly, we're talking about speed. And if you remember from the notes, speed, if it's increasing, it's speeding up. That's only when acceleration and velocity have the same sign. So positive and negative, that means it's slowing down. Negative and negative means it's speeding up. Negative and positive means it's slowing down. Positive and positive means it's speeding up. Now, the points where it's at rest are the times where the velocity is 0. Now, the only time where the velocities are 0 is at A and C. And so that's it. Now, I know that seems like a lot of information and a lot of practice, but I think this really helps you get a feeling for what all of these different things mean and how they relate. So the rest of your delta math is pretty straightforward. The particle motion from a graph, one at rest means you're looking for where velocity is 0. Just make sure you're paying attention to the sign up here, whether it's giving you a velocity graph or a position graph. Once we get into finding distance, that's that last question. I think the examples they give you are pretty straightforward. You're finding where they change directions. So you're going to find the max and mins, and then you're going to calculate the distance from each one. So -5 up to 4, and you can use your graphing calculator as well. But when you go -5 up to 4, that means you traveled a total of 9 blocks up vertically. So then you add all of your distances together to get the total distance. I think it's pretty straightforward. As far as from an equation, again, the examples are really helpful. This particular one, the speed of the particle when it's 2, you just plug in 2. There are a couple different types of questions with this one. Just follow the examples if you get stuck, and feel free to ask me additional questions if you have any.